Hello students, I am Ruchira Mukherjee. Today we are going to study chapter 11, Chemistry of Nonmetals. Chemistry of Nonmetals. So what are nonmetals? In chemistry, nonmetal is a chemical element. Nonmetal is a chemical element that mostly lacks metallic attributes. Physically, nonmetals tend to be highly volatile, have low elasticity, and are good insulators of heat and electricity. Chemically, they tend to have high ionization energy and electronegativity values and gain or share electrons when they react with other elements or compounds. 17 elements are generally classified as nonmetals. Most are gases such as hydrogen, helium, nitrogen, oxygen, fluorine, neon, chlorine, argon, krypton, xenon, and radon. One is liquid, that is bromine, and few are solids such as carbon, phosphorus, sulfur, selenium, and iodine. So, students, now I will tell you physical properties of nonmetals. So, nonmetals have about malleability. Non-metals are not malleable, but they are brittle. Brittle means they break easily, such as sulfur, phosphorus, etc. About ductility, so non-metals are not ductile. We cannot draw them into wires. Silicon, boron, are the examples of non-metals and they are not ductile. Metals have one more property, that is sonorous, but non-metals are not sonorous. That means it cannot produce sound when hit with a hammer. Bromine, fluorine, etc. are the examples of non-metals and they are not sonorous. Density. Non-metals generally have low density. Non-metals generally have low density. Example, hydrogen, carbon, etc. About hardness and softness, non-metals are generally soft. Non-metals are generally soft, such as carbon, phosphorus, etc. Conductor of heat and electricity. Non-metals are generally bad conductors of heat and electricity. Non-metals are generally bad conductors of heat and electricity. Iodine, neon are the examples. But carbon in the form of graphite, which is a non-metal, but it conducts electricity. But it conducts electricity just like metals. What about luster? Iodine is a non-metal which is lustrous, having a shining surface, just like metals, but other non-metals have no luster. About hardness and softness, so alkali metals such as lithium, sodium and potassium are soft, just like non-metals. Carbon in the form of diamond is a non-metal and it is extremely hard, just like metals. their state, mercury is a metal, but it is liquid at room temperature. And some non-metals are found in gaseous form. Generally they are found in gaseous form. Mercury found in liquid form at room temperature. And now melting and boiling point. Sodium, potassium, cesium and gallium metals have low melting point. Sodium, potassium, cesium and gallium metals have low melting points. Diamond is a non-metal which has a very high melting point and boiling point. So now about density. Alkali metals, lithium, sodium and potassium have low densities just like non-metals. It means non-metals have also very low density. Now students, what is allotropy? What is allotropy? You may be aware that both graphite and diamond are forms of carbon. Both are made up of carbon atoms. How it is possible that two substances that look so different are actually forms of the same substance? Diamond glitter, whereas you know about carbon, it is of black color. So there is a lot of difference in their form of substance, but in their looks they are so different, but they are the same forms of same substance, that is carbon. Now just carbon, not only carbon, but many other elements are found in more than one form in the same state. Elements found in more than one form in the same state, this property of element is known as allotropy, and the different forms of substances are known as allotropes. So what is allotropy? Elements are found in more than one form. Elements are found in more than one form in the same state. This property of element is known as allotropy, and the different forms of substance is known as allotropes. So the bonding between atoms in different allotropes is different, leading to difference in some physical properties. Since the atoms of different allotropes of an element are identical, therefore the chemical reaction shown by them are same. Such as graphite and diamond, both are the forms of carbon. They are the allotropes of carbon. On combustion, they give carbon dioxide. Oxygen, phosphorus and sulfurs are some other non-metals that exhibit allotropy. So students, I will tell you about non-metals in periodic table. Where do non-metals in the periodic table? So students, where do non-metals lie in the periodic table? Students, this is periodic table, and you have learned about periodic table already. So, can you tell me an element is a metal or non-metal by looking its position in periodic table? Students, as we move from left to right, in a periodic table, there is a decrease in metallic character. There is decrease in metallic character. When, as we move from left to right in periodic table, there is a decrease in metallic character. That is, as the group number increases, the metallic character decreases. As the number of group is greater, the metallic character will be less. So, as the group number increases, metallic character decreases. If we look at the elements of the first group, then we find that all its elements except hydrogen are metals. But we will not find a single metal in the elements of group 18. This is group 18. We will not find a single metal in group 18. If we look at the elements in the particular group, then there is an increase in the metallic characters as we go down in the group. As we go down in the group, the metallic characters increases. There is an increase in metallic character as we go down the group. Such as if we take group 15. If we take group 15, then the first two elements, nitrogen and phosphorus. Nitrogen and phosphorus are non-metals. The fourth and the fifth elements. The fourth and fifth elements, that is arsenic, Sb means antimony. These are fourth and fifth elements of the group 15. They show some metallic characters, but are not completely metal. They show some properties of metal. However, the last number, that is bismuth, of the same group is a metal. Nitrogen and phosphorus, these are not metals, they are non-metals. Arsenic and antimony have some properties of metals, but this bismuth of the same group is a metal. These two are, nitrogen and phosphorus, are non-metal. Arsenic and antimony shows some characters of metal, and bismuth, which is the last member of 15th group, is metal. There are some properties that are exhibited only by metals, while there are other properties that are shown only by non-metals, and we have seen those properties. How metals are different from non-metals. We have seen their properties. However, we also find some elements that show some properties of metal and other of non-metals. That is their property lies somewhere in the middle of metal and non-metal. In the periodic table, these elements are located between metals and non-metals. That is why they don't see a sudden change in metallic group as we move from the group, as we move from one group to the next. The change is stepwise. stepwise. This behavior is seen in elements situated along with zigzag diagonal line in the periodic table. The elements are counted among metals, but they are called metalloids. So, what are metalloids? Metalloids show some properties of metals and some properties of non-metals. They don't have all the properties of metal or non-metals. So some elements possesses properties of both metals and non-metals. These are known as metalloids. Some elements possesses the properties of both metals and non-metals. These are known as metalloids. Example: boron, silicon, germanium, etc. Boron, silicon and germanium. These are metalloids. So students, metalloids include boron, silicon, germanium, arsenic, antimony, tellurium and polonium. Just like metals, the metalloids are also found as solids. Boron and silicon are poor conductors of electricity, but addition of impurities leads to electrical conductivity. Some metalloids are found in solid state. Boron and silicon are poor conductors of electricity, but when they are not in pure form, they may lead to the electrical conductivity. All these elements do not belong to the metals, and all elements that do not belong to metals and metalloids group, those elements that do not belong to metals and metalloid groups are called non-metals. Now students, non-metals include one member carbon of group 14. Carbon of group 14. Two members, nitrogen and phosphorus. Two members, nitrogen and phosphorus of group 15. And three members, oxygen, sulfur and selenium of group 16. Non-metals include one member, that is carbon, it is from group 14. Two members, nitrogen and phosphorus, they are from group 15. And oxygen, sulfur and selenium are from group 16. Group 17 is known as halogen group, and 5 of its members, fluorine, chlorine, iodine, bromine and astatine, are non-metals. Since halogens require only one electron to complete their octave, therefore they are very reactive. They are not found in free state. And were recognized only near the end of the 18th century. So students, there are 5 members: fluorine, chlorine, iodine, bromine and astatine. These are non-metals and they are halogens. They are called halogen. This group 17 is known as halogen group, and these 5 members, fluorine, chlorine, iodine, bromine and astatine, belongs to halogen group, and they are non-metals. these halogens require only one electron to complete their octet. Therefore, they are very reactive. They are not found in free state in nature and were recognized only near the end of 18th century. चूँकि इनको ऑक्टेट बनाने के लिए, हेलोजेंस को ऑक्टेट बनाने के लिए सिर्फ एक इलेक्ट्रॉन की ज़रूरत पड़ती है, तो ये बहुत ज़्यादा रिएक्टिव होते हैं और इसीलिए फ्री फॉर्म में नेचर में नहीं मिलते हैं. 18th सेंचुरी में, एंड ऑफ द 18th सेंचुरी में इन हेलोजन ग्रुप्स के मेंबर्स को रिकॉग्नाइज किया गया. एंड 18th group 18 is consist of noble gases. Is a big group of non-metals. All the noble gases belongs to group 18 are non-metals. It includes the colorless gases such as helium, neon, krypton, argon, xenon and radon. Since the outermost shells of noble gases have electrons, 8 electrons, therefore they do not normally take part in chemical reactions. चूँकि उनके पास लास्ट ऑर्बिट में, आउटरमोस्ट ऑर्बिट में या आउटरमोस्ट शेल में 8 इलेक्ट्रॉन्स होते हैं और उनका जो ऑक्टेट है वो कंप्लीट हो चुका होता है, इसीलिए उन्हें किसी से इलेक्ट्रॉन्स लेने की या अदर एलिमेंट्स को इलेक्ट्रॉन देने की आवश्यकता ही नहीं पड़ती और इसीलिए वो किसी केमिकल रिएक्शन में पार्टिसिपेट नहीं करते और निष्क्रिय बने रहते, इनर्ट बने रहते हैं. दे आर ऑल्सो नोन एज इनर्ट गैसेस. सो तो 18 ग्रुप्स में जो भी नोबल गैसेस आती है वो किसी के साथ रिएक्ट नहीं करती क्योंकि उनका ऑक्टेट कंप्लीट हो चुका होता है और इन गैसेस को इनर्ट गैसेस कहते हैं. इनमें लैक ऑफ रिएक्टिविटी पाई जाती है. सिंस दे आर फाउंड इन ट्रेस अमाउंट इन द एटमॉस्फेयर दे आर कॉल्ड रेयर गैसेस. तो इनको नोबल गैसेस भी कहा जाता है, रेयर गैसेस भी कहा जाता है. नोबल गैसेस इसीलिए कहते हैं क्योंकि ये बहुत लो, इनकी रिएक्टिविटी बहुत लेस होती है, लैक ऑफ रिएक्टिविटी, रिएक्ट ही नहीं होते किसी के साथ. और इनको रेयर गैस भी इसीलिए कहा जाता है क्योंकि ये एटमॉस्फेयर में सिर्फ ट्रेसेस में पाए जाते हैं. एंड एलिमेंट्स विच इज़ नॉन मेटल but which has been placed on the left side in the periodic table. Can you think of any element which is a non-metal but which has been placed on the left side of the left side in the periodic table? So before we study more about non-metals, we will read little bit of the history of non-metals, and I will tell you it about the discovery of non-metals or history of non-metals in my next video. Thank you, students. Thank you for listening.